right, so in this video, we're going to take a look at how the calculator will find the area under the normal curve. We're going to look at how we could do this without the calculator first, briefly, and then how we will use the calculator. So we have something called a z-value or a z-score. And that gives us a number of standard deviations between the original measurement, which we're going to call x, and the mean. We're calling that's the mu, the u shape of the distribution. So we're going to use this formula, x minus the mean over the standard deviation in words. Okay, so first thing we're going to do is draw a nice normal curve for this. Do the best you can sketching that in. I'm going to put the mean in the middle, which is 17 for this scenario. So it takes an average of 17 minutes with a standard deviation of 3 minutes to drive from home, park the car, and walk to an early class. So 17, we're going to add 3 going to the right, will be 20, 23, and 26. And then we're going to subtract 3 going to the left. We're going to do that for the 3 standard deviations. And then one day it took the student 14 minutes to get to class. How many standard deviations from the mean is that? So let's take a look. Here is our mean of 17. That's right here. You have to go 1 to the left for 14. So it's 1, that's a little bit weird color there, 1 standard deviation to the left. Another way we could say that is -1 standard deviations. Okay. This one says another day it took the students 21 minutes to get to class. How many standard deviations from the mean is that? If we look at our graph, 21 is not on there, so we need to use that z-score or z-value option and do 21 minus 17, which is the mean, over 3, which is the standard deviation. That comes out to 4/3, which we're going to approximate as 1.33. And that's how many standard deviations from the mean we are. So we can't use our approximate percentages if we don't get an exact 1, 2, 3, 4, whatever standard deviations from the mean. I just realized I put standards instead of standard. So let's get rid of that. Okay, so how is that going to apply? We want to, if we were going to use a non-calculator method, we would use this big chart that we have. I have a little snippet of the chart on the notes. So if we want to figure out if it takes less than 18 minutes to get to class, we need a z-value for 18 to use that chart. So we're going to calculate the z-value and do 18 minus 17 over 3, new z-value. Again, that comes out to 0.333 repeating. I'm going to round that to 0.33 for the chart purposes. We're going to be finding the probability that z is less than or equal to 0.33. We have a chart for that. So if you drew a picture, let's think about what's happening here, and that's going to be our main goal, is to sketch out the picture. Here's 0, here's a standard deviation of 1, 0.33 is like 1/3 of the way there. We'll just say that's a good estimate, and then we're going to shade in everything to the left. So we should get something that's a little bit more than that 50% or 0.5 probability-wise. The way we locate that on the chart is we're going to look for 0.3 down here, and we're going to look for the 0.03 here, because if you do 0.3 plus 0.03, that adds up to 0.33. And we're going to find that intersection. So this is how we would do this pre-calculator era. We had all these different statistics charts we can get the information from. These are also approximate like they were before because I rounded this 0.33 off. It was really a repeating decimal. And I'll have the whole chart available in class for you to look at what the bigger version of that looks like. The other option is to use your calculator. So we're going to take a pause, stop this video, and the rest is going to involve using the calculator and the different uses of the calculator. I'll just show you where that's going to be. It's going to be second VARS distribution, and we're going to be using normal CDF.